Hi, welcome to Lithium Deep Dives, episode one. My name is Clay. I'm the founder of a blockchain called Lithium, and we're doing a show on our channel called Deep Dives, where we're going to be introducing you to Lithium itself, just everything you could possibly want to know about how proof of performance works and why we're building Lithium and all this sort of stuff. Eventually, we'll be going through the whole white paper and just talking through every little detail. But today, one of our investors offered to introduce us to their dev community. So we've started a little presentation for them. And I just wanted to present that here, right? I figured, if we're preparing all this, why not just show it to the public? So here it is. This is going to be a very brief overview. And also it's targeted for app developers. So right now we're in what we're calling phase one of our testnet, which is all about the DApp development, right? So we've got the EVM is working, it's JSON RPC compatible, MetaMask, Hardhat, all these normal tools work. And so we're just focusing on getting the message out there to technical people who may be interested in a new type of consensus that we think solves a lot of problems. So generally, what are we going to be talking about today is why blockchains are intentionally limited, how it affects you, and how Lithium is fixing the problem. And these words intentionally limited we've used very purposefully, right? Because I think one thing that people maybe fail to realize is that the bottlenecks that we have in blockchains are very different from the bottlenecks we have in traditional systems, right? It's not that the CPU is pegged or you've run out of memory or bandwidth or something, right? Blockchains have a bottleneck of a different sort, and we intentionally limit them. And it's not until you sort of understand why this is that you can maybe think about finding a solution. But because blockchains are intentionally limited, you have sort of a difficult choice as a DApp developer. Now, first of all, if you're choosing a blockchain or a L2 or whatever, you're of course going to be going for a place with the biggest community. And admittedly, because we're just in a testnet now, we don't necessarily have the biggest community yet. But I'm hoping that by the end of this, I can convince you that Lithium eventually will have the biggest community. We certainly have the potential to have the biggest community. But besides the community aspect, you have sort of a big technical problem, which is that if you choose to go with Ethereum, you have a situation where you're priced out by Uniswap and Aave. In other words, the gas price is going to be too high. Like, you just can't build much there, right? Ethereum goes at the speed of an Apple II, and it's meant to be used by everyone on the planet, I guess. I mean, that's totally unrealistic, but at least that's it's one computer for everybody, and it only goes as fast as a computer from 1979. If you just think about gas as a metric for clock speed, right? Your other choice is to run on one of these alternative systems, but you probably have questions about the decentralization, right? Because we're all living in this world where supposedly there's this trilemma and you have to choose between decentralization and scale. But maybe even more basically, like you're going to have to run an RPC node, right? This whole paradigm that we have in the Web3 space for the infrastructure, I just realized I'm wearing my headphones for no reason, is done in a way where, although you can only communicate with a blockchain trustlessly by running your own node, your end users expect to be able to just connect to a node that you run, right? So, for example, if you're on Uniswap, there's a uniswap.org node running that your Web3.js connects to. Funny enough, MetaMask connects to a different node, right? So because people just expect the wallet to work regardless of whether they're on a DApp website or anywhere else, and you can't really trust a node that's just given to you from a website necessarily, the wallet connects to Infura, right? And so if you're going to choose one of these, high scale chains, you're also expected to run that RPC node, but it's going to cost you a lot more, right? This data comes from, so this is just to show that on Ethereum, you're kind of priced out. If you go to a very useful website called ultrasound.money that all the Ethereum community loves to talk about because, it's deflationary ether or whatever. But one of the really interesting data points they have there is this burn leaderboard. And this basically just shows you which dApps are getting the most usage in terms of just monetary value. Like, what are people willing to pay for, right? As measured by the gas burn. And you can see that everything here is just DeFi, right? It's a bunch of routers, and Aave isn't here, I think, or maybe it is and it's got a different name. But, if you're trying to do SocialFi or GameFi or even a competing DEX or something in the DeFi space, you're kind of just priced out by this. If you want to run these other networks, even something like Multiverse, EGLD, is pretty expensive, even though they have this sharding thing. It's still quite expensive. And then, of course, you have the complication of the sharding, right, which is, I think, highly questionable. And they don't really answer questions to my satisfaction as far as like what happens if a transaction hits all of the shards in one transaction, or, what exactly is the extra like big O cost of bandwidth from when you have to switch shards, right? Because you're bouncing between shards if you're a node in the network, because you can't let people just choose what shard they're in. So you have to like always be shuffling them around and moving them to other shards. But then you have this cross shard communication stuff that has to happen, which further increases the cost of the RPCs. So I'd love to know, like, how do the costs of these things grow with usage of the network? But they don't really tend to answer those questions, at least not in the white papers or in their documentation. You also have this issue where it's like you as an RPC runner, you need to suffer the cost imposed from everyone else in the network, right? So it's like, even if your DApp is quite small or you just launched it a month ago, you still have to run a giant node that allows you to synchronize the entire network, right? Because even if you're only interested in some slice of data, like just the wallets that are maybe in your DApp, or maybe just the smart contract that your DApp is involved with, or the tokens that it's interacting with, you still have to validate the whole block potentially, right? Otherwise, you're still just depending on some other node. So that's a problem, right? Even these high scale blockchains are intentionally limited, and it really ruins everything, right? Just to put a kind of point on that, it's like the limit is also extremely restrictive, right? When you're talking about these sort of top tier chains, which I think are limited for a very legitimate reason, like they don't just arbitrarily decide to make Bitcoin 1 megabyte or 2 megabyte, 2 virtual megabytes or whatever it is, and limit Ethereum to 30 million gas per block for no reason, right? There is a reason. I don't think the reason is necessarily very well understood, or at least it's not described publicly very well, but there is a legitimate problem if you do try to scale the chain, and the impact is absolutely like amazing, right? I mean, like if everybody wanted to make just one Bitcoin or Ethereum transaction, it would take 30 years. That's pretty limited. You can also kind of illustrate this disconnect in the fact that you have all this capital which goes towards the things which are incentivized, which, if you're looking at Bitcoin, we're talking about $100 billion. But then they are proud of the fact that the full node is so cheap, right? And they say like, oh, you can run it on just like a $20 computer Raspberry Pi that you plug into your, commodity at home internet connection, right? This is seen as a good thing, right? But like, this is like a huge disconnect. And obviously running the infrastructure or having the actual like function of the blockchain have to run on such a limited device has huge negatives to it, right? It's not just a positive thing because everyone can run a node. It's also a negative because the node can't do anything. The problem is similar on Ethereum, right? This one little NUC boy meme is from the Ethereum community. So they're proud that they're able to run a node on such limited machines. But you think when you see this, you got 40 billion. I mean, these are old numbers. I don't know about the 100 billion, the 40 billion. They're kind of estimates are out of date. But if you have all this capital at play, you think maybe you could get some performance out of the network, right? Another way to look at that is like, if you have $100 billion on Bitcoin, you still have a network that can only do 7 transactions per second. Whereas if you were to deploy that amount of capital into cloud infrastructure, you'd have something that could do something maybe in the order of 7 billion things or 7 billion transactions per second. So there's, maybe a billion-fold difference in performance per dollar when you deploy capital into these networks, right? And the funny thing is, despite the fact that they're so limited, we still can't even really deliver decentralization, right? I think Jack understood this when he, looks at the sort of some of the business models that are happening around the space, right? And he said, you don't own Web3. VCs and their LPs do. I'm not sure if he was just talking about, the ownership of the tokens and the exposure there, but there's another issue where it's like, how are you getting data from the blockchain? And don't we just have like a regular old Web 2 big data business model at the core of a lot of these things? The Ethereum community doesn't like to talk about it, but, there was a period when Parity, I guess, they were thinking about, so for people who don't know, Parity is Gavin Wood's company that was maintaining the Rust implementation of the Ethereum node, which was called Parity or Parity Ethereum at the time. They ended up rolling that off into Polkadot, and they, refactored to create an EVM compatibility layer for Polkadot, and Parity Ethereum died. But before all that happened, they were, very open about criticizing these very real problems, right? Unfortunately, because everyone's sort of trying to protect themselves, you don't get this level of honesty a lot of times out of these communities. But yeah, if we don't stop relying on Infura, the vision of Ethereum failed. This was a guy working for Parity, right? Gavin Wood is I believe, a founder or co-founder of the Ethereum Foundation. So you'd think that these folks would know what they're talking about. This is also shocking from the same article. So this is CoinDesk. These got picked up all over the blockchain media space at the time in late 2001 or 2021. You can see in the same article, they also had some quotes from Michael Wooler, the co-founder of Infura, and he was also open about some of these problems, right? If every single DApp in the world is pointed to Infura and we decided to turn that off, the DApps would stop working. We're supporting the entire Ethereum ecosystem. Any DApp that uses MetaMask also inherently depends on Infura. In that sense, nearly all dApps potentially depend on Infura. We didn't create the problem. We were just abandoning on the problem, right? So, there is, if you are looking for it, quite a lot of legitimate criticisms of what's going on here as far as like, how are we delivering this USP we call decentralization to the end user? This is Moxie Marlin Spike wrote a really great article. I think this also might have been 2021. He actually built a few dApps and deployed them just to see what was going on in the Web3 space. For people who don't know, Moxie Marlin Spike is the founder of Signal. And yeah, he wrote this blog called My First Impressions of Web3 that was pretty damning. It's actually a great article. There's a lot more stuff in here than what I've pointed out. But, the client APIs are not using anything to verify blockchain state or the authenticity of responses, right? This is the JSON RPC. It doesn't have any way to authenticate, to convince the wallet that the data that it's getting is actually from the blockchain, right? You just trust the node that's giving you the information. Virtually all clients that wish to access it do by simply trusting the output from these two companies without further verification. That's Infura and Alchemy he was referring to. From the very beginning, these technologies immediately tended towards centralization through platforms in order to them to be realized. Now he was talking about it being like sticky if you standardize something, and it's very hard to pivot. And so he saw it as more of like a startup value creation kind of a thing. But I totally disagree with him on that, actually. I think all of his criticisms are very, very valid. But I think the reason we have these problems, he didn't quite understand, because it all stems from this lack of scale, right? It would, if a wallet could connect to the blockchain, then it would. But you can't connect to the blockchain. You can only connect to a node. Now, proof of work offers a way of actually solving this particular problem that he's talking about here, because you can see the difficult hash in the block header. And if you know how difficult the difficulty is currently on a proof of work system, then you can sort of safely assume that block header was legitimate. And then because you have the Merkle proof in the block header, the Merkle root in the block header, if somebody sends you a Merkle proof that includes your transaction, then you can be reasonably sure that that's correct, that transaction is in the block. But we threw all that out with proof of stake. And even with proof of work, we never had, none of the wallets actually do any of this, right? And part of the problem is like, why would Infura want to bother with that, right? Like, it costs them money to produce those proofs. They have to build like a whole index in order to quickly produce proofs for you, filtered by like whatever transactions you're interested to see. That's not cheap, right? So if you can just not do it and nobody complains, then that's what you do, because this is big data, not Web3. So that's a bit of a problem. Greg Maxwell, Bitcoin core developer, right, just pointing out the problem is that as Bitcoin transaction volume increases, larger companies will likely be the only ones running Bitcoin nodes because of the inherent cost, right? That's the problem. That's why these RPCs impact the decentralization, and why we ultimately intentionally limit these sizes, right? And this is from Mike Hearn. So people who maybe don't know who Mike Hearn is, he actually worked at the same on the same team that I was at Google, called AdSpam, although he left before I got there. But I managed to leverage that into a conversation with him a few years ago. But the sad thing is that he totally left, and he was number 3 after Satoshi. So Satoshi, and then he gave Gavin Andreessen the repo, or the keys to the repo. And Mike Hearn was usually regarded as the third in line, sort of, as far as contributors. I don't know if that's really true. I've looked at the Git logs, actually, and there was a lot of other people, like Greg Maxwell in particular, and a bunch of other folks who ended up going the BTC Blockstream route, who were also big contributors. But Mike quit in 2016, and he said that Bitcoin failed, right? So that's how strongly he felt about this issue. Yeah. Many Bitcoin users and observers have been assuming that up until very recently that somehow these problems would all sort themselves out. And of course, the blockchain size limit would be raised. After all, why would the Bitcoin community, the community that has championed the blockchain as the future of finance, deliberately kill itself by strangling the chain in its grip? I think he also is more leaning towards it being like a conspiracy of Chinese miners, actually, he says in his blog. But I think he actually hasn't really been honest with himself about like what the underlying causes are, right? There are, like I said, it's not just some conspiracy. There are legitimate reasons that you need to limit these blockchains, and it all comes down to those RPCs we'll talk about in a minute. And I just want to point out that, even if you're running, you're paying this cost on Solana or Multiverse X, these are also centralized, right? Even if you're running your own node, from your user's perspective, they're trusting your node to give them this data. So, you're damned if you do, damned if you don't. Whether you're running a highly limited chain or one of these ones that sort of pretends it's not a problem and just imposes these giant RPC costs on everybody, it's still all failing to deliver secure data to the end user, right? And yeah, so, I hope that kind of starts to answer the question of why we intentionally limit blockchains, right? It's these RPC costs, right? They need to be kept low, because the only way that you can trustlessly communicate with a blockchain is by running a node yourself, right? Because the answer, if you tell people in these communities like, oh, I can't securely connect to the network unless, via Infura, right? If you start talking about Infura, they'll say, oh, well, you can always run your own node, right? But if that's the fallback position, then running your own node must be cheap. Right. And so that's sort of why. And you can also find the blog post where Vitalik introduced this idea of the trilemma. It's not very rigorous, actually, this concept, but he basically said that decentralization means you have to be able to run a node on your laptop. I don't think that's a very good definition. Actually, he said it's typically interpreted to mean that it has to run on a laptop. I think he knows that that's not a very strong definition, which is why he worded it that way. But yeah, we sort of see that that's, based on this assumption that you really should be running, like, the node is a wallet, right? And if you look at the RPCs, funny enough, you'll see that like the original design of the RPCs treats them like a wallet. Now, I've listed the RPCs here just to get an idea about what sort of when you view it as a kind of like a server client model, what is it that the node has to do? And this is the Bitcoin RPC that I've listed on the right here. And then I've kind of tried to categorize like RPCs into groups of like what a node actually has to do. The interesting thing to think about is like that only really get block and maybe like get block header and some of the other stuff that's like maybe indirectly, about block synchronization is incentivized, right? Because if I make a block, if I'm a miner and I make a block, I want to send that to everyone, and everyone wants to get that from me because they want to mine on top of it, right? So you can directly interpret that as a consensus over the RPC. But all these other RPCs, there's no consensus, right? And this is sort of how Litheum thinks about a blockchain, right? It is everything that a blockchain does is an RPC. It's a network application. And so you can just sort of categorize all its functions by just listing out all the RPCs. And our philosophy is that you have to pay for everything, right? And then you don't need the full nodes. But we kind of categorize them into these things. You can think about block propagation, we say, is like partially decentralized, because if I am a miner and I have a block, but it's not my block, I don't want to get it to anyone, right? All the other miners are my competitors. And so I don't want to send it to anyone. And again, like a full node has to be able to do that work, right? Because the network itself, in a sense, isn't incentivized to send blocks to anyone unless that person made the block. But then you have the question of like, how do I find the person who made the block, right? So you get into the peer-to-peer metadata stuff, or what we're calling peer discovery here. And that's not incentivized at all, right? If I'm a miner, I don't want to tell anyone about the other miners in the network because I'm trying to compete with them. So why should I help you find them? Transaction propagation also is a very interesting one, because there's actually sort of a disincentive for people to propagate transactions. If I'm a miner and I get a transaction, I'd rather mine it myself than give it to somebody else, right? So this is sort of a way to understand the underlying cause of the reason why we intentionally limit blockchains, or why, the top tier blockchains are the most limited, is maybe another way to say it. So yeah, what is it about proof of performance that sets it apart? Well, another way to think about it is that we unify the difficulty and the RPCs, right? Providing the RPCs or RPC service is the difficulty. Part of the way we achieve that is that we use the fee as a difficulty. So in other words, in order to make a block, the block producers need to collect enough fees from transactions. Basically, you can think of it as you have to have enough transactions to make a block. That's been used by Slimcoin and some other blockchains in the past. But the cool thing about that is you sort of empower the wallets to demand service from the blockchain, right? Because it's like, I'm not going to give you my fee unless you give me some data. And so basically all the RPCs that are sent out from the chain are signed with a proof. And then when they come back in, that proof is included. And then that makes it a valid transaction, and therefore a valid fee, and therefore valid difficulty. And one way to think about the result of this is that you end up in a sense with, all your capital that's deployed for difficulty gives you sort of free RPCs. It's not free in the sense that like you don't have to pay for it, but that you were going to pay for it anyway because it was the security, right? The way we think about other difficulties is that they're sort of difficult for the sake of being difficult, but don't do anything else, right? You need a difficulty or something that's difficult in order to create a consensus, because the difficulty basically serves as a incentive, like to do the right thing. Because then if you do the difficult thing and in the right way, you get rewarded and offsets the difficulty. But if you do the difficult thing in a bad way, not in the consensus, by making an old block or by making an invalid block or whatever, it serves as a penalty, right? So we have this concept of a difficulty, but it's only difficult for the sake of being difficult. It doesn't do anything else. And so another way to think about Litheum is that we are taking the difficulty and making it do something useful, which is all the things the blockchain should do. So yeah, once you do that, you sort of align these two things, what we call the security and the scale, or the decentralization and the performance, which is why it's called proof of performance. And you end up with a chain which can potentially push the cost of transactions down to the physical limitations, right? Of course, you still want to constrain the consensus so that you have enough nodes to call it decentralized, but we basically have a difficulty adjustment algorithm that adjusts the gas price, the difficulty in terms of fee, and the staking for what we call the runners, and it targets a specific number of runners in the same sense that it targets a specific block time. So a little bit complicated difficulty adjustment algorithm. We can deep dive on all that stuff in the future if you're interested to know more. Yeah, we're going to be doing AMAs, and also our community is still quite small. So if you have questions, I know that probably people are going to have a ton of questions because we sort of just glossed over the solution there at the end. But I just wanted to sort of present, a very brief overview of what we're doing. But yeah, if you've got questions, jump in our Telegram. We've got a small community, so we're happy to answer questions. We're going to be doing AMAs soon. This channel, our YouTube channel, if you're watching this on YouTube, is going to have a lot more videos in the future. We're just getting to a testnet at this point. So we're in what we're calling phase 1 of our testnet, which is all about getting EVM compatibility and the JSON RPCs working, and getting some DApp developers hopefully involved. At this stage, we're going to have a builders program. It's actually already formulated. We've got the website for it, or the landing page, and all the information is built already. It's on our staging server. We haven't launched it yet. We're going through some press releases with our media partners to present that soon. And so you can look for that if you follow us on Twitter, or just jump in Telegram or whatever. We'll be pushing out announcements about that soon. So I hope to see you there. And thank you for your time. Thank you for your interest. Thank you for any questions. And we'll see you next time. Bye-bye.